In panel C, we'll now compare the Cournot-Nash equilibrium to the equilibrium that would emerge under Bertrand price competition and the equilibrium that would emerge if the two firms became a single monopoly. Now suppose that the two firms got together and decided to behave as a single monopolist. We know that a single monopolist would produce the quantity XM. XM appears on the vertical axis, and it also appears on the horizontal axis. And the line that connects the two XMs contains combinations of quantities for the two firms that sum to the monopoly quantity. If the two firms colluded and decided to jointly produce the monopoly quantity, each producing half, we would then end up at point M in the picture. Given that C lies to the northeast of point M, we know that under Cournot-Nash competition, the two firms will produce greater output than they would if they behaved as a single monopolist. Under Bertrand price competition, we know that price will be competed down to marginal cost, and when price is equal to marginal cost, the quantity demanded is equal to X star from panel B of graph 25.2. X star also appears as one of the intercepts of each of the best response functions. So if we connect those two intercepts, any quantity combination that lies on that blue dotted line will sum to the quantity X star. When both firms set price equal to marginal cost, it's reasonable to assume that they'll split the market and will end up producing at point B, with each firm producing the monopoly quantity that's half the quantity of X star. We can then see that the Nash equilibrium quantity that's produced under Cournot competition is less than the Nash equilibrium quantity that's produced under Bertrand price competition, but more than would be produced if only a single firm was producing in the market. After we cover Stackelberg sequential quantity competition in graph 25.4, you'll also be able to see that the Stackelberg quantity combination will lie at the intersection of the horizontal line that passes through M and the vertical line that connects B to XM on the horizontal axis.